All right, so we're going to evaluate piecewise functions real quick. And when you do that, you want to remember, first of all, that f of x equals y. And this is a point x, y, okay? And first we're going to determine which domain or x's contain the value that you are looking for. And then we're going to plug it into the function. Well, that says the function into the correct function. No, let's not say function. We're going to plug it into the equation, into the correct function. No, I don't like that word either. Let's say we're going to plug in the value into the correct function. All right, so this is our x value, f of x, f of 2. So f of x, so x is 2. And we want to know what y value that is, okay? And so we say, where does 2 fall? Is 2 less than 0 or is 2 greater than 0? Well, 2 is not less than 0, so it doesn't fall here. It falls here, so it falls in the bottom here. Okay, so that means that in order to calculate f of 2, we would say 2 minus 1. We would use the bottom equation, and that would be 1. So the point that we would get is the x value we plugged in and the y value we got. So we could plug this in and get a point. So what if we plug in a number and we get a number, we get a point, okay? So for this one, f of negative 2, well, where does negative 2 fall? Well, negative 2 is less than 0, so this is the top. So we would say 2 times negative 2 plus 1. So negative 4 plus 1 is negative 3. And so this is the point, negative 2, negative 3. This is 5. So 5 is greater than 0. So this is the bottom. And so we would say 2 times 5 plus 2. 10 plus 5 is 10 plus 2 is 12, and so this is the point 5, 12. F of 0. Now, they both have 0, but which one includes the 0? That's this equals 2 here. So this here is the bottom. So we would say 2 times 0 plus 2 is 2, and so we get the point 0, 2. 1 is greater than 0, so that's the bottom as well. And so we'd say 2 times 1 plus 2. 2 times 1 is 2, plus 2 is 4. And so we get the point 1, 4. So it's not that we plug it in every place. We have to find the correct place that we plug it in, okay? So 3 times, where does negative 2 fall in? Well, negative 2 would be here, but it's not equal to. So we actually are going to plug it in this middle part. So we put the middle here. So we say negative times negative 2. So the opposite of negative 2 is 2. So this would be negative 2, 2 if we were doing ordered pairs. This 3 falls here in the bottom. So this is the bottom here. So we say 3 squared minus 7 times 3. So 9 minus 21 is negative. My math's not working. 9 minus 21 is negative 12. I think that's right. And so you'd say 3 negative 12. Somebody's going to call and say, Miss Smith, you didn't do that math right. That's right. Okay. And then negative 4 falls here. So this is the top. And so we say 3 times negative 4 is negative 12 minus 2 is negative 14. And so this would be the point negative 4, negative 14. And 1 you would normally think falls here, but it really falls here because of the equal sign. So we'd say 1 squared minus 7 times 1. So 1 minus 7 is negative 6, or the point 1, negative 6. All right, you try, pause the video and try these 7 down here, and I'll give you the answers in just a minute. So this is the top, and this is equal to negative 1 cubed, which is negative 1. This is the middle, which is the point 0.01. This is the bottom, which is 3 times 1 plus 2, which is 5. This is the bottom, which is 3 times 3 plus 2. 9 plus 2 is 11. This is the top. So this is negative 2 cubed, which is negative 8. This is the top, which is negative 7 cubed, which I'm going to need to use my calculator for that. Negative 7 cubed is negative 343. And this is the bottom. So this is 3 times 8, which is 24, plus 2 is equal to 26. All right, so when you're doing piecewise functions applications, you do them same way you've been doing them. They're just word problems. So first, you're going to determine the domain, which is just the x's for each piece of the word problem. And then you're going to write an equation for each sentence or piece of the function. And then you're going to graph the piecewise. So if we look at these 2 examples down here, ooh, that chicken scratch looks bad. Hopefully you were listening along. So the admission rates at an amusement park as follows. So children 5 years old and under are free, and children between 5 years and 12 years. So those are our X values. So 5 years old and under are free. So this is our X's. So if you are less than 5 years old, then you're free. 5 years old and under and free. Now, can we just say less than 5? Yes, but we should say that they are between 0 and 5, right? Because honestly, children don't go to negatives. And the function value that goes with that is how much does it cost us? Well, it costs us nothing to go in if they're 0 to 5. Well, if their values are between 5 and 12, inclusive, they said, and we've already included the 12 over here, so we can't include, the 5 over here, so we can't include the 5 over here, then the cost of that is $10. And if they're between 12 years and 18 years, so now we're including the 18 over here, the cost is $25. And anybody that is above 18 is $35. So there's our piecewise function. And then it says, write an equation, a piecewise function that gives the admission price for a given age. So I guess we could put X's on them if we were like saying how many people were coming in, but it didn't tell us that. It didn't tell us to do that. And so they're saying for a given age. So basically your graph is going to say From 0 to 5, it costs us nothing. So from 0 to 5, it costs nothing. And from 5 over here to 12, oops, I put that in the wrong place. The y value is 10, so it should be up here, right? So it should be from 5 to 12, it costs them $10. Because remember, this is the y value here. So 25, so now we're going up to 25 at 12. From 12 to 18, right? And then we're going up to 35. So at 18, that should be open, even though it's hard to see. Let's see if I can make it open. And up, it's 35. So there's your piecewise. All right. So over here it says you have a job where you make $10 per hour. So this is $10 per hour, basically, right? It says write a piecewise function where you're paid for up to 60 hours. It says after you work 40 hours, you get paid time and a half. Well, so from 0 to 40, right? You get paid $10 an hour. Yes? Then more than 40, you get paid time and a half. Well, what does that mean? Well, it means that I take this 10 times x and I multiply it by 1.5. So I could clean that up and I could say that 10 times 1.5 is 15x. I could write it as 15x, or I could leave it like this. And then it says you may only work a maximum of 60 hours. So really this isn't correct, because we wouldn't say x is greater than 40 because we can't go forever. We can only go to 60 hours. So our time for time and a half is really from 40 to 60. And that's our piecewise function. Now remember, this is 15x here. That'll help us graph it. So then when we're graphing, we just say from 0 to 40 is 10x. So we're going up 10. So these are, if I go up 1 and over 1, that basically is 10, right? Because look at it. That's up $10, up 50 over 5. 50 divided by 5 is what? Well, that's 10, right? So each of these is 10. So from 0 to 40, I'm going to go up 1 over 1 all the way to 40 here. Okay. And then from 40 to 60, I want to go time and a half. So I want to go 1 and a half. So up 1, up 1 and a half, time and a half. So that's like 3 halves, right? Because 1.5 is the same as 3 halves. So I'm going to go 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. But I can only go to 60. That's this one, right? So that's where I'm going to there. So there's my graph. So that's all you do. Figure out the domain, figure out the functions, graph the function.